All right, hopefully you're able to watch video number 1 here. This is just a follow-up, kind of continuing where we left off here. So let's talk about a couple of the main, I guess, important families on the periodic table. Now, hey, if you ask a chemist which ones are important, he'll tell you, he or she will tell you all of them, right? Because they love all of the 118 elements. And by the way, today we talked about in class the fact that about 25 of these elements are necessary for human beings to live, right? We need these with, again, this is kind of just a little bonus thing here. The ones that we need, we call them the big four, okay? These major elements are, in fact, hydrogen, carbon, nitrogen, and oxygen here, okay? So maybe I'll just put a little dot here, hydrogen, all right? In addition to these guys are right beside each other, carbon, nitrogen, and oxygen, okay? All right, so let's talk about some of these families here. So the first one that I would like you to know here is called the Alkali Nettles here. So I'm going to just kind of go over them in green. So the Alkali Nettles, all right here on the far left side. Now remember, these are called families, all right? Families or groups. Now, you can label them based off of number here. So here's group 1, group 2, okay? Going down the line here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then picking it back up here, 13, all the way to 18. All right, so you can call them, group 1, okay, group 2, group 3. But again, the families are a little bit more specific, like the way that we're classifying them. These are how they're more commonly referred to as, okay, so it's important to know. So here we have the alkali nettles here, all right, so lithium, sodium, potassium, rubidium, cesium, francium. All right, right next door, the next door neighbor here, all right, is again, a very similar name, all right, the alkaline earth metals here in blue in group number 2, but the family is called alkaline earth metals. And folks, the way that I think about this, it's an easy way to remember these are called families, because families think that your genes from your grandparents to your parents to you are passed down the line. Your genes are passed down to you, okay? Now, you can also think you grow up with your family, all right? So just think about that. You grow up with your family, or genes are passed down to you. So families run this way. A little side note, okay, periods run left to right, almost like a sentence. So I'll draw an arrow here, how they run. Periods run this way, all right? So families run north and south, okay? Periods run east and west, okay? Like a sentence. Think about it like this, okay? I can make a sentence. I wish it was sandwich, because I could really use a sandwich right now. You put a period at the end, right? I can make a sentence. Okay, periods go at the end of sentences. Periods run left to right. Okay, so right here, smack dab in the middle, this actually makes up the largest, the most here. These are called the transition metals here. All this big chunk in the middle, in addition to down here as well. Now, more specifically, okay, these are known as the lanthanoids and actinoids. All right, so these guys have their own. They're also called like the rare earth elements. Okay, rare earth elements. But if you know them as the transition metals, I am happy. I'm happy with that, okay? So the transition metals here in purple, okay? Skipping over here, now these names here, they kind of get like, I don't know if they're not as cool, they just get neglected, okay? But the families here, very simple, right? This group 13 here is called the boron family, all right? Group 14 here, carbon, known as the carbon family, okay? The nitrogen, oh, you guessed it, the nitrogen family, and oxygen, nope. Just kidding. It actually is the oxygen family. All right, not very creative with the name, so those ones are actually very easy to remember, to be honest. But we have 2 here at the end, just like how we started with 2 here. We have 2 at the end that have some different different names. Okay, so let's go with the, actually I should probably get, okay, I'm grabbing another marker here. So for our halogens group, okay, I'm gonna do these in brown, okay, the halogens group number 17 out here on the end, so 17, the halogens, and the last group in yellow here, all right, the noble gases, all right, the noble gas, a very special group right there. They don't react with anything, right? They don't like to make bonds or form compounds, right? They are happy because they have a full outer shell, which will actually transition us into our next step. So hopefully this helps paint a nice picture here of the main groups on the periodic table. So you'll do an activity with this map where you'll see specifically, you'll see it'll be broken down into non-metals, okay, and metalloids, but I broke those down in the last video. So here's just kind of like an overview of the periodic table. So again, as you can remember, most of the periodic table is in fact metals, okay, with a slight portion being non-metals and then metalloids, those half metals, half non-metals, okay. So let me just show you one. I'll actually flip out here. Flip out, oh no, that's not good, right? I'm gonna show you here on this one, okay. So we showed you the families and periods. So again, I just want you to see, again, as we had in this one, right? Family number 1, 2, 3, 4, 5, right? But now the periods, also, you can think of them over, they run this way, right? So this would be period number 1 running here, just hydrogen and helium. Very small period there, all right? Here would be period 2, right? Running lithium, beryllium, all the way across, right? Etc. All the way over. Period 3, period 4, period 5, period 6, period 7. Okay, now if you're wondering about the lanthanides here, remember, here's this is like, they're like moving, okay? We needed a little bit of space on the periodic table, so we say that they fit right in here, okay? So here is where these two go, okay? So this group is in period number 6, and the bottom one here, okay, the actinoids group 7, okay? Now, what does that tell us? Like, why does it matter which period? Well, actually, the periods really tell us the number. What they do is tell us the number of shells, all right, that, so I'll make like one little note of this here. So the period number, all right, so the period number tells us the number of shells of electrons that an element has. Okay, so that's what the period number does. So let's flip it over here. So period number 4, potassium is going to have 1, 2, 3, 4 shells of electrons. All right, so I can show you an example here in a moment. Now, what's the family number tell us? Okay, the family number. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 through 18. Okay, what's that tell us? Well, the family number, okay, tells us the number of valence electrons that an element has. All right, so you may remember valence. Remember, those are our valuable outer electrons that are responsible for forming bonds, okay, with other elements, right, to form compounds. Okay, so the family number. Now we have some number. Those family numbers run even in like the, what about 13, 14, 15, right? Well, you look at the last number. Okay, so 13 has 3 valence electrons. Family number 15 has 5 valence electrons. Okay, so even now group 1, or excuse me, family 1, family 2, hey, just one valence electron, or family 2, just 2 valence electrons. All right, so it doesn't matter where you're at. So right here in the fluorine group, all right, right here over in the halogens, this is period number, or family number 17. okay? So they have 7 valence electrons, okay? 7 outer shell electrons. So I hope that that helps to clear some things up for you here. Maybe I can show you an example here, all right? So sodium, let's go for the period number. Period number tells us the number of shells. So here we go. Let's go. Sodium has 3 shells, all right? So let's just take a look here. So here's sodium, Na. Shell 1 can only hold 2 electrons, 1, 2, all right? Now we know if it's balanced, we know that sodium, if it's balanced, it's neutral, it has 11 protons, right? Because its atomic number is 11, so it has 11 protons. So so I need 11 electrons on. So there's 1, 2. All right, so the second shell can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. That gives me 10. So I need another shell, 11. All right, so it's in group. It's in period number 3. So it has 3 shells of electrons. Now, let me show you an example with so that's kind of, this would be, remember going back to that period number, what that tells us. So let's check out that family number, right? So that family number tells us the number of valence or valuable outer electrons here. Okay, so let's look at nitrogen being in group, or excuse me, in family number 15 there, the nitrogen family. All right, so that's telling you that's going to have 5 valence or outer valuable electrons. So let's see. So nitrogen, we know, has 7. Its atomic number 7. Okay, so nitrogen, we could draw it here, so I could draw it. So nitrogen, 1, 2 electrons. I need 7. 3, 4, 5, 6, 7. All right, now, how many does that leave me in the outer shell? Well, let's kind of count them up. Here we go. 1, 2, 3, 4, 5. Oh, it checks out perfect. All right, so again, some tips and tricks there with the periodic table. Again, it is beautifully organized, right? Every location, every placement of the element is perfect, and you can't pull it out, or it's going to be like a Jenga tower that just collapses. All right, so hopefully you enjoyed this video. If you liked it, if you have more questions about the periodic table, I'll attach or I'll link my other YouTube video on my periodic table of elements lunch. All right, so again, thanks for tuning in. Hope it was helpful. All right, everyone, peace.